So the reaction we are given here is an alkene plus water. The alkene we're given is a cis-2-methyl-butene. Let's draw the structural formula for the alkene first. We have 4 carbons in the parent chain. Let's number them. Let's number the carbons. 1, 2, 3, 4. On the second carbon, we have a double bond. On the second carbon, we also have a metal branch. Let's draw the insignificant hydrogens. On the third carbon, we have 2 options to put the insignificant hydrogen. We can either put it at the bottom or at the top. Since the alkene we're given is a cis, the insignificant hydrogen has to go at the top. The structural formula for water is bent like that because of the lone pairs on the oxygen. When alkenes are hydrated, meaning when alkenes react with water in presence of an acid catalyst, they produce an alcohol. In our case, we're going to use a sulfuric acid at 100 degrees Celsius in our reaction. A catalyst is just a substance or compound that makes the reaction go faster. This whole reaction is called an addition reaction. In addition reaction, we're just adding groups or atoms to the chain by breaking the pi bond. The pi bond is the bond at the top right here. The one at the bottom is a sigma bond, but we don't really need to worry about it right now. We break the pi bond because carbon can make up to 4 bonds. This carbon has already made 4 bonds. 1, 2, 3, 4. Same goes for carbon number 3. 1, 2, 3, 4. If we break this pi bond, let's say we remove this pi bond. Now each carbon number 2 and carbon number 3, has 3 bonds. 1, 2, 3, 1, 2, 3. So we can add 1 more groups or bonds on carbon number 2 and on carbon number 3. So in the reaction, one of these bonds is going to get broken. Let's just break this bond. And this hydrogen has the option to go on carbon number 2 or carbon number 3. But according to Markovnikov's rule, a carbon involved in the double bond that started the reaction with more hydrogen should get this hydrogen. Between carbon number 2 and carbon number 3, clearly carbon number 3 has more hydrogen. Carbon number 2 has 0 hydrogen. Carbon number 3 has 1 hydrogen. So according to Markovnikov's rule, this hydrogen can go on carbon number 3. This OH will then go on carbon number 2. Let's say all the H's in this reaction are friends. Now this H has the option to go on carbon number 2 or carbon number 3. If this H goes on carbon number 2, it will have no friends because on carbon number 2 there are 0 hydrogens. On carbon number 3 there is 1 hydrogen, which means if this H goes on carbon number 3, it will have 1 friend. So this H will definitely want to go to a friend rather than go to carbon number 2 and be alone by itself. Let's just now draw the structural formula for our product. 4 carbons, no double bond anymore because we broke the pi bond there. Let's number our carbons. 1, 2, 3, 4. On carbon number 2, we have the metal branch. on carbon number 2, we also have the OH hydroxyl group. Let's draw the insignificant hydrogens. If you noticed, I skipped a hydrogen here because this hydrogen is now significant because it was involved in the reaction. This hydrogen is this hydrogen that was involved in the reaction. Now, let's circle the branch here. Let's name this product here, this alcohol. We have a metal on carbon number 2, so 2 metal. On carbon, we have in total 4 carbons in the parent chain, so but, and since we have the OH on carbon number 2, we're just going to write 2 OL. This OL indicates that it is an alcohol. Follow-up question we have here is, how could you modify your reactant so that Markovnikov's rule would not apply? In this particular alkene, we can just remove the branch here so that Markovnikov's rule would not apply. Now, let's write this alkene without the metal branch. We have 4 carbons here. 1, 2, 3, 4. Let's number the carbons. 1, 2, 3, 4. On the second carbon, we still have the double bond. Throw the insignificant hydrogens. We have insignificant hydrogen on carbon number 2 at the top. To keep this modified alkene as close as the alkene we're given there, we're going to put the insignificant hydrogen at the top. We could have easily put the insignificant hydrogen at the bottom, but the alkene would then be a trans. So we just want to keep it as close as to the alkene we're given, so that it is a cis plus water. And now let's try to name this alkene. So it is definitely a cis. We have 4 carbons in the parent chain, but. We have a double bond on carbon number 2, 2 ene plus water. We're going to have the same catalyst, H2SO4 sulfuric acid at 100 degrees Celsius or plus 100 degrees Celsius. H2SO4 at 100 degrees Celsius. Same procedure will be done here. Break the pi bond. In the water, one of the bonds will be broken. So let's break this bond. This hydrogen can now go on carbon number 2 or carbon number 3. Both carbons have the same number of hydrogens. Both have 1 hydrogen. In this case, Markovnikov's rule will not apply because both carbons involved in the double bond, which are carbon number 2 and carbon number 3, they both have the same number of hydrogens. So this hydrogen can either go on carbon number 2 or carbon number 3. So let's just put this hydrogen on carbon number 3. This OH will then go to on carbon number 2. This hydrogen could have easily gone to carbon number 2, and this OH could have easily gone to carbon number 3, because Markovnikov's rule would not apply in this particular alkene, because Both carbons involved in the double bond both have the same number of hydrogens. The analogy that I showed you earlier would not apply in this reaction because both carbons involved in the double bond have the same number of hydrogens, which means this H now has a friend on carbon number 2 and on carbon number 3. It is up to the H to choose where it wants to go. In this reaction, it chose carbon number 3. It could have easily chosen carbon number 2 because there is also a friend on carbon number 2. Now, let's draw the product. We have 4 carbons in the parent chain, no double bond because we broke the pi bond there. Let's number the carbons. 1, 2, 3, 4. On carbon number 2, we have the OH hydroxyl group. On carbon number 3, we have a significant hydrogen because this hydrogen was involved in the reaction. So we're going to have to write the H there because it has become a significant hydrogen there. Toss in the insignificant hydrogens. And now we're ready to name this alcohol, this product. We don't have any branch, so we're going straight into the parent chain. We have 4 carbons in the parent chain, so butane. We have hydroxyl group on carbon number 2, so 2OL. So that's how you modify this alkene cis to methyl butene so that Markovnikov's rule would not apply.